Alright, today we're going to take a look at B-splines. B-splines are a way to kind of express an arbitrary function in terms of some simple functions, and those simple functions are the B-splines. And they kind of look like this. This is a second quadratic spline. They're kind of smooth in some region, and then they go to zero, and they're zero outside that region. And try to see if there's another picture. There's not. So we're gonna try to construct some of those. So I already made a basic Raylib project here. It doesn't really do anything. So the first thing I want to do is to have the ability to plot something. So probably want to take a couple of arrays, and we want like the x's, we want the y's, and the number of points, and then we also want where to plot it. So we're gonna need to get like the minimum x and the maximum x, and same thing for y, like that. So here I'm just gonna let Copilot do it because that's kind of trivial. So now we have that, and now we need to plot some points. So let's say so let's get the x value out. Let's get the y value out, and let's actually get the next value like that, because then we can basically draw a line between them. So x, y, next x, y, and some kind of color. We're gonna make it like a what is this? This is a light color. Let's make it red. So kind of a red color. Now the problem with this is that these x and y values have probably nothing to do with the screen coordinates. So we kind of have to convert those to screen coordinates. So for that reason, let's do the following. Plot star x, that is the location, the end location. We actually want some kind of margin, I think. So let's put like 10 pixels of margin. So this is going to be plus plot margin, this is going to be minus, and the same here. And there we go. So we have these numbers, we want to put them into this range. So to that end, we're going to make a function called lerp, which takes a value, and it takes from start, from end, to start, to end. And what it does is it calculates a t value, which is like value from where it started, divided by the full range, like that. And then the final value is going that same fraction between the end and the start of the target range. Okay. So what we really want to do is want to linear interpolate this thing from the start x to, sorry, it's going from minimum x to maximum x, and it has to go for this range in the plotting. So it's basically the same. Copilot can do that. And now when we plot it, it should be fine. So let's go ahead and make something here. gonna just allocate some stuff, and then we can go here and we can include math, and then it says random value, but I don't really want this. Let's say we have start x is 0 and index is just 1, maybe times pi times 2, something like that. And then we need the dx, I suppose. And there we go. So this thing, that can be sine of x. And here we're going to say plot arrays, x's, y's, so many points. And I actually want to make a rectangle for the window. And it's right now it's just 800, but let's actually pull that out into a variable. So it's going to be like this, and then we actually do it again, but it's going to be height. And it's not going to be a variable, it's going to be a macro. So then we're going to make a plot window. Here I also want to define a margin, and it can be 20 for this one. And we do this, and we do the plot window. Let's see how that works. So kind of gave a lot of warnings. Right, so actually I want to do something that I think is a good habit. Let's do warn all, warn extra, and turn warnings into an error. Do that. Okay, so now it doesn't compile because we need to include stdlib. And there's an unused variable, and that is also an error, because here I actually need to say window x, window y, window width, and window height. All right, so that's kind of working. Let's also draw some lines, and I'm also gonna make those red, because why not? And maybe I will even make this one blue. Actually, let's try to make it blue. I think something like 200. It's kind of a nice blue. Can we do something in Raylib where we have a thickness? So we can do this thing, kind of thing. Draw a line. Because I think it could be nice if we have a little bit of thickness, like 3 pixels. Let's try that. So it looks a little bit better, I think. Okay, so now we can plot functions. Now we should try to actually make one of these splines. So the first thing it needs is something that's called nuts. So those are basically some set of points that, first of all, like if you have m points, you have m splines, and those points are kind of like where the splines go to a maximum value. So let's go here and say B-splines. Just gonna do this, and the first thing we need is the number of grid points. So it says control points. Copilot, I guess we can call it control points, and we want like tmin. We can say that it's again from 0 to 1. And now let's make some t's. actually, there's kind of two things we need. We need the control points, and we need just the number of points. That can be 100. So like this, and then we can say control points, I guess. And that's those. All right, so let's actually do this, and let's fill these in. And I don't need any lerp, I guess. Well, we can actually use this. We can actually use the lerp function for this. I didn't think about that, but we can do that. And now the same thing here. We fill that in. Yeah, so that is that. So now we have these points, and we also have kind of a grid of values for these t's, which would be like the x-axis here. So let's try to make the first, the 0th order spline, that's degree 0 spline. So I think I want a function. Let's just make a 0th order spline. So I think I want an array where the values are going to be put in. Then I want the t values because we need that. Then I need the control points. And we also need the number of points, and we need the control point index. And I think that should do it. So here we go. The first one is very simple. If t is between ti and ti plus 1, it's 1, otherwise it's 0. So we are going to loop through the points. And let's get the t value. That's this, and the next value is this one. Sorry, I plus 1. And that means we have to do like that. And then we can say what is the control t, that is the control point index. And now if the control t, and what did it say? We also, sorry, we don't need that, but we do need the next control t. And that's kind of plus 1, so we're gonna have to assume that, yeah, let's do to do bounce checking. Okay, so now if t is greater than the control point less than the next one, we set to 1, otherwise we set to 0. So I think that's pretty good. Let us now create a spline like this, and then we will make it where we just take this array we just allocated, the t values, the number of points, the control points, and then we need an index. So here I kind of want to put it sort of in the middle, so let's do that. And let's now try to plot it. And we call it spline, number of points, and we are going to have an issue here because we redefined number of points, so I'm just going to comment this out. And let's see if that compiles. So it compiles. Okay, now we already see a problem with the plotting. It's kind of upside down, so let's go fix that. The reason is that in pixel coordinates, higher y is, if you increase y, you go downwards. So I think we can fix it by just saying, actually, this is the end and this is the start. Yeah, now it's working correctly. So you can see here that it kind of yeah, it's just kind of like a step function. It's 0 and then suddenly it becomes 1. So that's pretty simple. And if we go ahead and like decrease this, you can see it moves. Before it was over here, now it's a little bit to the left. So So that is all well and good. But now let's try to make, so now we have this one bi0, so let's try to make bi1, which you can see from this formula, it depends, BIP depends on BIP minus 1 and bi plus 1, comma bi minus 1. So that means if we want to get the fourth one, we actually also need the fifth one. And now we're going to say spline 4, sure, spline 5, and we can create these. And then we can say, okay, this value, like we don't need it anymore. So we can override it. So we're going to put it into this. We're going to need the previous one as well. We need this one, the control points. Actually, we can simplify it a bit. We can just say, no, we can't. We need the index. Sorry about that. There we go. So this function that we haven't written, it's going to override the first argument with the new values. So let's go ahead and make it like this. So float star. This is an integer. Let's get this on the next line so I can see what's happening. And an integer control point index. All right, so here we go. Now we need to loop over the points again. In this instance, no, I think we're good. So let's get the t, that's just this. And then we need ti plus p. So actually we also need the order here. We also need, what is the order? Because it tells us how far to look ahead. What am I doing? So here we go, the order is 1. Order equals 1. So we have that. So let's get ti. It's this one. Let's get tip. Okay, it's plus the order. And then over here we need tip plus 1 and ti plus 1. So ti1 is this, tip1 is that. And now we have to do this multiplication. Let me take it over here. So spline, and this should not be called spline 4, it should be called just a spline, maybe spline next. So spline of I should be equal to t minus ti divided by tip minus ti times the previous value of the spline, all right, plus tip1 minus t, tip1 minus ti1 times spline next of I. So we just translated the formula directly. So now we're making that, we're making this one, spline 4, and we're still going to plot that. And that didn't work because we renamed these things. All right, so now you see that's a little bit funky. Let's make a few more points. Yeah, that's a bit better. So now you see this one is kind of a step function. What we can do is we can plot spline 5 at the same time, so you can see it's also an interesting point, I think, how those splines like relate. So this is 4 and 1. They don't overlap at all. They're just right next to each other. If I make the next one, you can see it becomes this like triangle thing, and it also starts to overlap with the other one. So what if we like want one more? Can go ahead and do this. And now you can see, I thought you could see something. It's because we need to make that one 6 here. Now we have two triangles, and actually this value here is 1/2, I think. So if you sum them up, they always give 1. And we can actually try that just for fun. Endpoints, I++, and we say spline 4i is equal to spline 5. We add that. So now you can see in this overlap region they're equal to 1, and outside they go to 0, but that's because if we had spline 3 we could add that. All right. So that property, by the way, is this one, where if you add them all up, then you get 1. So we have, where did I choose 8? Let's do 20. Maybe let's just do 10. Still don't like it. Let's try this. This is kind of a nice amount. So okay, let's not overthink it. Let's do 10. Okay. And now we can try to go even further. We should be able to go here and make the next order. We need the first order 4 and first order 5, but we already created those. And then we need to increase this one to 2. So now it's become the smooth function rather than a triangle function. So let us go ahead and create yet another spline so we can do this. That something clearly went wrong there. That's because this has to be 6. Okay. So now you can see we have these two smooth functions, and you can imagine creating like many functions like that. But it's a bit annoying. Look, I have to do all of this stuff. So I would really like something like calling a function that says create splines. Okay. I give it the t's, I give it the control points, I give it the order I want, and I think that's it. That's all. Well, I also need to give like the number of points, but that's just bookkeeping. So I give it the number of points, I give it the number of control points. And what it returns is some kind of structure, which we can call B-splines. So it gives me some splines here. And that just contains these splines here. So let's try to think about what should be in the B-spline structure. Okay, B-splines. First of all, we need an array for each single spline, and we kind of want them to cover the full range of t's. So you can see how this summation thing only holds for t between t p and t m minus p. So we actually need extra control points if we want to be able to sum to 1 at t equals 0 and sum to 1 at t equals the end. We need extra points. Okay, so we need control grid. Let's call it control points anyway. And we need the number of control points. Let's also store the order there. And then we need a bunch of values. So how many values do we need? So originally we're asking for these control points, but this is more like, this is not the number of splines we want, this is more like, this is more the number of points where we want to be able to describe any function, and this thing, I think it's quite central to being able to describe any function, so we have to have that one. Okay, so control points, now for control points order, and then I suppose we are kind of gonna store the grid as well, and then I think we can do this. It's kind of like we're just gonna have one big array that contains all of the splines. So let's try to create this function. So here's the t's, number of points, control points, number of control points, and the order. Okay. So how many splines do we need? So number of splines, and we need one for each point, but then we also need to, because this thing only holds between, even though we're summing from 0, this formula only holds for t between tp and tm minus b, so we need p extra on the left and p extra on the right. So we need the number of control points plus 2 times the order. That's how many we need. And how do we create those? Maybe we're gonna say, and this one I think we call it splines. So let's see alloc this many. But the problem is we also need to extend the t grid. Yeah, so let's say dt is and then we have extended t's. That is going to be this, and we also maybe we want extended control points, which is this, but this one is not quite right. Let's say extra points. That is going to be let's say extra control t. That is going to be order times dt. So the extra points, that's going to be, and then we actually need, so this is the d control point, and we need the actual dt, which is t1 minus t0, and this is this thing. Yeah, and this is not quite right. I feel like I'm making it slightly more complicated than it needs to be. So extra control T minus and plus I times dt. And let's fill this one out as well. And that one is also kind of wrong. Oh. Minus extra control T, like that. Okay. So I think this will give us the extended grids. So let's try to just fill all those with some 0th order splines. So number of control points is not quite right because I want to fill out everything. So I'm gonna have here like spline start. That's gonna be splines, but yeah, plus this thing. Except not really, because it's really number extended points. Right, so number of extended points. So this thing is, we need a pointer to the start of the spline thing, that's this. Then we need the extended t's, and then we need number of extended points. Actually, let me put those to the same line. Then the extended control points, and then the I. And what's the I again? That is the just the control point index. Okay, let's now make this structure, and I want to just replace, like get a new line of these places. So we have the extended control points, we have how many control points, the order, which for now the order is actually 0, the extended t's, the extended points, the splines, and then let's return that. And let's just try to call that function and see if it, well, it does not gonna work because I'm trying to plot something I just commented out, but let's try here. Okay. So that didn't work because the order, we kind of want to go to 3. Let's just go to 3. Now this thing is unused, that thing is unused, so I'm gonna, now all of this is unused, that's a little bit annoying. And okay, I'm regretting it again, so I am just going to do this. And that didn't work, Accidentally quit out. And there is some segmentation fault happening. Where exactly? So let's not call this, and it should be just fine. We can call this, and now what? So the splines, number of, that's the problem, it has to be the number of extended points. Okay. So we got that. Let's try to plot one of them. So plot arrays, and it's going to be splines, and let's plot 4. So +4 actually. And the t's and the number of points. Yeah, I thought something might go wrong there. Because this one has now stored the extended, which is kind of wrong. It has to store only the t's. Yeah, but then when you index them, okay, that's a bit annoying because I think we don't want the splines to be defined in other places. It's just going to be super annoying. So we're going to do this, and then we're going to fill them out afterwards. And we're not going to do this. We are going to loop over the points. And it's going to be spline j is equal to extended spline this. So every time we go to a new spline, this is I, we skip this many, and then we also skip the extra points. Extra points on the left, and then we do that. And then here we say splines, t's, and points. And that also gave some kind of segfault, which is always nice. Spline here. And could that be from here? No, it is still somewhere in this function that creates the splines. Okay, splines, we allocate it. We loop over them. What is this number of splines? That's probably wrong. Yeah, that's wrong. So actually here it has to be number of control points. But I don't think that was it. So it's probably this code, right? So if I don't do that, it's fine. So here we go into the extended splines for each. And actually, is there a problem here, kind of? Because I do want to skip the first ones, so I want to skip those. And number of extended points. Number of extra points. So this is only going to make it worse, right? So, but still. Yeah, that's it. Okay. looks super wrong, and that is because we need to say splines dot number of points. We need to skip 4 of those. I think. Yeah, great. So the problem is we need the t's first. Great. So I think that's correct. We can plot a few of them. Like 0. Let's do it like this. And there, that looks right. We can increase this one a little bit and we go all the way up there. Okay, so in this way, we can get splines on the original points that we specified. The t's, the control points, all of that stuff, everything that we specified originally, we still have down here. We need to remove this. I think this is, no, I think I still want that. I still want that. Because now we're gonna go ahead and say for I equal to 1, I less than order, we're gonna do some stuff. We need to loop over the number of new control points. So let me actually pull this one out. The number of extended control points is that thing, right? Yes. And then we loop over all the splines and we apply this formula. So we loop over all the splines except the last one. So we have to say for int j0, j less than number of the control points plus 2 times order. It has minus I. Why does it have minus I? But that sounds right. It's because we're going to be missing one every time we do it, so we actually have to say minus I. Okay. So pointer to start of the spline is this thing. The next spline is that thing. Then we simply go in and do the stuff. The function we already used. And let's try to run it. But I want to do order 1 first. That didn't do anything. Because we did this, it has to be equal to. Alright, that kind of worked. That kind of worked. I'm very surprised. So let's go to order 3 and we get these beautiful, beautiful functions. And now we can kind of play around with it. We can even like do very high order, like 6. And you can see it's kind of a weird thing happening where they shift a lot. Like the peak is here now, and if I go to 6, the peak is outside. So I think that's definitely a bug. So that is unfortunate. I think I want to do something. So to mouse is this, and if we are colliding, we can do this. So now we're kind of drawing the coordinates of the mouse. And why does it say 1? That's also, there's definitely something wrong. Plot start x, and let's move it down a little bit. And also, so that's almost fine. There we go. Okay. So this is supposed to be 0, 0. It is not in the y. And why is that? So it does seem like it's going from 0 to 1 in x, almost. That we can actually check. So for I less than number of points, ti is this thing, let's say 4. Run that, and here we have all the t's, and you can see that they do go from 0 to 1 as they should. Great, but that's not really showing here, and I think that's probably because there's something wrong with my interpolation math here. And could it be this potentially? No, that's correct. So maybe it's just because saying it's 0 here. I mean, maybe that is correct. If we just decrease the order here. No. Well, we do have a control point at 0, so actually I think that is correct. I think that's correct. Let's go ahead and make these order 1, so it's a bit easier to see like exactly where things are. And now we have this problem with the y. So let's have a look at that 0, I less than number of points. And I want to take just, let's say, spline I is this thing. So we run that, and it goes from 0 close to 1, very close to 1, and then down again, which is exactly what I would expect. But when we hover, it's not showing that. Which is very weird. What is minimum y and maximum y? That does look correct. So why does it show 2? That should not happen. It's because, okay, it's because I'm silly. So this you shouldn't need, and this probably also. Yeah. Yeah, now it makes sense. Now it makes a lot of sense. Now I'm a bit confused why. It's probably because, like, when you So the definition here says, yeah, it's like if it has a control point 0, it's one after that, and then it kind of moves to the right when you go to higher order. So I actually think this is correct. All right. Let's go ahead and do this. So now it's a bit unfortunate. So we actually need all of these splines on the extended control points. Yeah, I can just write extended here. So we need all of those. Go ahead with this, and that one can go away. And then I think we need to do something here. So splines get, it's called B-splines, get a spline pointer. And we go ahead and do this. So this spline index can go from minus. So we can do like assert spline index is greater than or equal to splines order, but actually minus that. And we can say assert that spline index is less than this. And then we're going to return this. So basically what I want is that when we say give me the 0th spline, it gives you the one that is supposed to start at 0. So we can go ahead and delete all this, and then we say B-splines get spline pointer. We take the splines and we say 0. And I should have done it like this. So B-splines get spline pointer splines 0. Okay, and like that. And we don't have assert, so let's include assert. And B-splines get spline PRT, which is wrong. Okay. So that looks different. What did I do before? I did 1, 2, 0, 1, and 2, and 6. 0, 1, and 2, and 6, but and now I have to change this back again. Great. So that's kind of weird. Why those different ways of doing it gives me different things. So is there a mistake in this one? What is the number of points? Number of points. I'm going to do control points. And number of control points. And what is that one? That is the order. So that's the problem. So this one has to actually now be the true order. T's is that. And endpoints is the number of points. Okay. Yes, so that makes more sense. And we have some intermediate things in here that we never free, like this one, we didn't free that. So let's free the extended T's, probably, extended control points, and the extended splines. So all the extended stuff, we free that. So you're not calling this function so much, so I think this malloc stuff is fine. This function doesn't look very clean, but it is what it is. Let's try to run it. No seg faults yet. We can get the spline, and now we can try to create like some function, some random function, and we can say like, let's do a superposition. So let's just call add splines. So it's going to take the splines, it's going to take the function where it puts them, and the splines already know the number of points, right? Yeah, so we don't need that again. And now we need some values. So let's say we have 0 of the first one. Then we have 1, so this much of that one, this much of that one. And let's do 0 and 0. And suppose we have to say how many values there are. We made 10, right? So let's assume we do the same here. So 0 and 0. Then we have add splines. It's not going to do anything. We'll take this type. It will take a function. It will take some floats, which we'll call coefficients. And that's it. Now the number of coefficients has to be splines, number of control points, minus 2 times splines.order. And now we are good to go. So we loop over all the points. We can set the function value to 0, yes. And then over all the coefficients, we get the coefficient and we get the pointer and the value. Okay. I suppose you can even, maybe you can even like inline that, this get pointer function, but make it a macro, maybe even better. So now we have this, and we can try to plot that function. We can plot it on top of everything. So that's never good when, yeah, this. So we plot that, and here we go. So that didn't work because, sorry, not integer but float. Can I do that? That doesn't work. How am I supposed to? Do I really have to do it like this? Coefficients. Okay, so now I do want to have support for, well, let's just remove those for now. We don't want to make this plotting thing super fancy. Let's do 5. So you can see we can like actually kind of make arbitrary functions in here, and just using these splines. We can even do like negative stuff. So we can make it go below 0. Now I can see this is negative. So actually with this thing you can do at least an approximate description. I don't know how to say it, but approximate approximation of every possible function. It's kind of weird that what if I do 9 here? What will I get? Just nothing. Huh. And if I do -2, I get something over there. Okay. Guess that's how it is. So if we want something more interesting, first of all, this one can go away, and let's do this. All right. So there you have it. So with these B-splines, you can make an approximation to any function using just a few numbers, even though it's like defined over the full range. And it has many uses in numerical mathematics. But I think that's it for this time. So I will see you in the next one. Bye bye.